Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's topic is structure of ethane, that is an example of alkanes according to hybridization concept. So let's begin. So the electronic configuration of carbon is like this, as the atomic number of carbon is 6. So 1s2, 2s2, 2px1, 2py1 and 2pz is empty, and this condition happens at its ground state. And when this carbon atom is at its excited state, then the electronic configuration at the excited state becomes 1s2, 2s1, 2px1, 2py1, because one electron from this 2s orbital has been jumped to 2pz orbital. So in ground state it was empty, but in excited state these are partially filled. So as this is the structure of ethane, that is CH3. So this situation is, for example, with this carbon atom. The similar situation would also happen with this carbon atom. So both of these carbon atoms would behave identically. And because these are saturated in nature, and here these are CH3 and other bond with the other carbon atom. So here 1, 2, 3 and 4, total 4 bonds are being formed, and for this situation these 4 atomic orbitals would intermix to form 4 sp3 hybrid orbitals. Now the next step comes towards their orientation. These sp3, for example, this is this carbon atom, okay, and these carbon atoms sp3 hybrid orbitals align themselves in this way. One orbital is here, other one is here. So now these are the sp3 hybrid orbitals of the one carbon atom, and the hybrid orbitals of the other carbon atom. How would these combine with these 3 hydrogen atoms? As one electron here, one here, and one electron would be here. So the 3 hydrogen atoms with this carbon atom would be shown like this. This is the 1s orbital of the hydrogen. Similarly, 1s orbital of hydrogen, 1s orbital of the hydrogen. So these 3 hydrogen atoms have combined with these 3 sp3 hybrid orbitals, and this carbon-carbon bond would be formed between these are the hybrid orbital of the other carbon, that is this one. So one electron from this sp3 hybrid orbital and one electron from this sp3 hybrid orbital. In this way, this would generate a sigma bond, and all these would be sigma bonds. Similarly, one electron of this sp3 hybrid orbital and these 3 hydrogen atoms have been shown here. So their simplified structure becomes like this. It is carbon-carbon here, then these 3 hydrogen atoms over here and these 3 hydrogen atoms are here. So in this way, the geometry along every carbon atom is still tetrahedron. Because if we consider this moiety, that is CH3, then its geometry is still in the tetrahedron shape, 1 here and 3 corners of the tetrahedron are here. And if we see the geometry of these hybrid orbitals and their combined 1s orbitals of the hydrogen, then still the situation is like this. They are shown in the tetrahedral shape. So in this way, the orbital diagram becomes like this. Here, this is the sigma bond, and all these are also sigma bonds. So total number of sigma bonds that are formed in the molecule of ethane are 3 over here, the 4th one, and 3 over here. So total number of sigma bonds are 7. So 7 sigma bonds have been formed in the ethane molecule, and their orbital diagram looks like this, and the simplified geometry can be sketched like this. And now the next point comes for their bond angle. If we consider this CH3, then still the bond angle becomes 109 degree, and on the basis of this bond angle, we have said that its geometry is tetrahedral in shape, or its geometry is tetrahedron, and it looks like it is of tetrahedral shape. Okay, so its geometry is tetrahedron. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.